Welcome to the robotics class for March 23rd. As I mentioned right before I turned on the recording, not everybody is in class today. I realize that some people are taking the ACT, so I'm going to record this for your benefit so you can watch it. The goal for today is I'm going to talk about the similarities and the differences between these little tabletop robots that we've been making up until now, the ones that are controlled by an Arduino, okay, and the quote unquote real robots, the big robots that we're going to be making next time we meet, because this is the last time that we're going to be teaching online here. Next time you see me, you'll see my real face, not just my face over Zoom. And we'll be working with real robots that use big motors, not these silly little yellow things, but the bigger ones, the real motors. Okay. Now the controller that we've been using up until now, we've been using the Arduino as the controller, basically the brain for the robot. The Arduino can still be the brain for the big robot. These Arduinos are amazing things. You can do great things with them. So when we make our first big robots, we're going to use the Arduino as the brain. And you'll find that you can do a whole lot of great stuff with it. And then after we've made those, then we'll switch out the Arduino for its big brother, which is called a Robo Rio. And we'll talk a little bit today about what is a Robo Rio and how it's different. So what I want to do right now is I want to talk about the similarities and the differences between the tabletop robots and the big robots that we are going to be using today, or I mean from now on. Okay, so let me start sharing my screen with you. All right, so this is a picture that should look very familiar to you. We have worked a lot with it over the last couple months. Okay, and so I just wanted to show you, I just want to remind you of how the power flows to the motor. And so let me turn on annotation here. Okay, so this is where the power actually comes from. The Arduino does not have enough power output to drive a motor. So what we have here is this here is the motor controller, and the Arduino is connected it. So the Arduino sends signals to the motor controller. And then depending on what the Arduino says to the motor controller, it then determines what to do with the motor and how to route the big power. Okay, so when the Arduino sends a signal to the motor controller telling it that it wants the motor to come on, then what's going to happen is the power is going to flow like this. It's going to come out of the big battery, it's going to go through the red wire. And by the way, the rules on color codes for wires are going to be strictly enforced in this class. Any wire that's connected to the positive side of the battery should always be a red wire. If I ever see you connect a black wire or green or any other color other than red, I'm going to make you redo it, because the rules are very strict, and they're strict for a reason. You need to be able to look at something at a glance and know which powers, which wires might cause danger to you if you were to touch them, or maybe danger to the robot if they're hooked up wrong. Okay, so the wire coming out of the battery pack is always going to be red, and it goes to the motor controller. So if the Arduino tells the motor controller that we want the motor to run, then the motor controller will send the electricity to the motor. Depending on, now, if we tell it we want it to run forward, then what's going to happen is it's going to send it through the motor one way. And notice these wires that go to the motor, they are neither red nor black. They are a different color. Now, I don't really care what color they are, as long as they're red, as long as they're not red or black. So in this case, I've got them as green and yellow. Okay, so if the current's going to flow through this, so it goes through the motor, causes the motor to run in the clockwise direction, comes out of the motor this way, comes along the motor here, goes in there, comes back into the motor controller. And from there, now you have to have a complete circuit in order for it to work. So it has to get back to the battery somehow. So it's going to go through the ground connection to the battery. And actually, at this point here, I really should switch to black, just so we're consistent with our color codes. Okay, so then the electricity comes out, goes to the ground bus, comes through here, goes to the black wire and back into the battery. So we have our complete circuit right there. Okay. Now, if the Arduino is telling the motor controller that it wants to run the motor backwards, then the path of the electricity, I mean, it's still going to be the same coming into the motor controller, but in this case, instead of going out to the green wire, it's going to go out to the blue wire. And so it's going to run backwards from what it did before. So that means the motor was going to run backwards from what it did before. Okay. And we have a couple other things in here. This is a push button switch that we were using before. Doesn't have to be a switch. It could be a sensor of any kind. It could be a proximity sensor, it could be a distance sensor. It's just something that feeds information to the Arduino. And then based on what information the Arduino is receiving, it's going to do different things with the motor. So like, for instance, let's say you want to drive the robot until it hits the wall. Okay, so this would be a switch, and when it hits the wall, then the switch activates, tells the Arduino that the robot has hit the wall. So the Arduino will then tell the motor controller to back up and turn and all those things that we did before. Okay, so this is a sensor input. Now the same thing's gonna be true with RoboRios. You can have sensor inputs. And also you can have various types of outputs as well. So this right here was a buzzer that we used as an output. So depending on the situation, maybe the Arduino is going to turn on the buzzer just to let the driver know that something has happened. Now the output doesn't have to be a buzzer. It could be a light, could be various other things. But basically, this is the architecture that we've been working with up until now. Now, compare this with the architecture on the bigger robots. So this looks overwhelming at first glance, but it shouldn't be too bad if we take it piece by piece. So let's talk about what are the various things. So this right here is the RoboRio. So it's basically the Arduino's big brother. Okay, it does the same thing that an Arduino would do, but it has a lot more inputs, has a lot more memory space, a lot more complexity. Just think of it as a RoboRio, or think of a RoboRio as if it was an Arduino's big brother. Okay, here is the battery. And this picture is not to scale. The battery is actually much bigger than what you see there. The battery is much bigger than the Arduino, or bigger than the RoboRio. In fact, it's bigger than all of these things that you see here. But to make it fit on the diagram here, whoever made up this diagram, they kind of shrunk the picture down. All right, so let's see. So if the RoboRio wants to tell the robot to move forward, okay, let's trace the flow. So first off, these are various types of motors. You can see here we've got 4 different motors all connected. And so let's just say we're interested in one motor here. And let's suppose that the Arduino has told the Arduino wants to tell the robot to move forward. Okay, so let's trace the electricity flow. Okay, it starts with the battery. And you'll notice we've got battery, we got red wires and we got black wires. So the red wire is where the electricity comes out. And it goes through this thing first right here. Okay, so this thing that you see right here, you see it's labeled the main breaker. All right, so somebody whose name is not Zane, tell me, what is a breaker and why would we want one? Nobody? Okay, Zane, can you tell us what is a breaker and why would we want one?
It's the electronics. So if something shorts out, then it'll stop it from shorting out completely and breaking everything else around it.
Okay, very good. So you guys have probably heard about fuses and you've probably heard about circuit breakers. So fuses and circuit breakers, they both serve the same purpose, which is exactly what Zane just described. If you make a mistake when you wire up the robot, so that two wires that should not be touching each other maybe are accidentally touching each other. So the electricity is going to, you're going to have way too much electricity flowing through there, and it could heat things up and could cause fires, and it could damage electrical components, can do a lot of bad stuff. And it's very easy to accidentally hook up wires the wrong way. So, I mean, up until now, we've been really lazy. We haven't we haven't put fuses or circuit breakers in our little robots up until now. The For a couple of reasons. One is I wanted to keep things really simple, but the other thing is that the batteries have been like 4.5 volts, which is not really enough to seriously damage most things. But with the big robots, we're using 12-volt batteries that could put out a lot of current if things are wrong. When we get back in school, I'm going to show you various wires and other things that have melted because people hooked them up wrong and too much current flowed through it, and they didn't have a fuse or a circuit breaker protecting it, and the wire melted, and it could have caught fire. So you definitely want to have something in there that can sense when you've got too much current flowing, and it's going to stop the current from flowing. Now, a fuse is something that stops the current flowing by, it's got a very thin little wire. And if that little wire gets too hot, the wire just burns up and it breaks and it opens up the circuit so electricity can't flow anymore. Now, if that happens, what you have to do is you have to take that fuse and throw it away, and you have to go to the store and buy a new fuse. Although hopefully you've gone to the store ahead of time and you have a good collection of fuses already in your drawer, hopefully. But basically, you have to throw that fuse away and you have to replace it with a new fuse, which works, but it's kind of a pain having to replace the fuse every time. So the other alternative is to use what's called a circuit breaker. And a circuit breaker is something that instead of it actually melting and being permanently destroyed, it just opens up. It has a nifty little thing that you've got these two wires that are touching each other, or two pieces of metal anyway, that are touching each other. And one of them is designed in such a way that when it gets hot, it curves and it breaks the electricity flow. But then when it cools down again, it straightens back up and it reconnects the electricity again. So in this case, it doesn't have to be thrown away and replaced with a new one. Now, there's different types of breakers. Some of them, when they get hot, they curve, and when they get cold, then they straighten back up again. Other times, when they get too hot, they flip over here and then they stay there. And so if you then want to put it back, you have to reach in and there's a little switch you have to flip in order to put it back. Okay, so but the neat thing about circuit breakers is that you can overload them so that they flip many times, and you just reset them. Whereas you can't do that with the fuse. You have to throw the fuse away. Okay, so this thing that you see right here, this is what we call the main breaker. Now, the reason we call it the main breaker is because it's not the only breaker. This thing that you're seeing right here, this is called the power distribution panel. And in fact, tell you what, I have another view of it here. Okay, so this is a close-up view of the power distribution panel. You want to use this in a big robot because, okay, so here's our big battery. Okay, so here's the plus side, here's the minus side. All right, so the plus side is going to be wired in here, and the minus side is going to be wired in here. And now I should have drawn the main breaker. So here, this is the main breaker right here. All right, so this is wired to the main breaker, and then the main breaker is wired to this. All right, so so if you get too much current flowing, the main breaker will flow, but you want to have additional protections. In a big robot, you might have 6, 7, 8, 9 different motors all running. And you want to protect each motor separately. And so what's going to happen is each one of these red and black pairs is a place where the wire can go out to the motor and then come back in. And so let's say you've got a motor going over there and you've got another motor going here. And then maybe you've got a smaller motor over here. And so you're going to have the electricity coming out that way and going in this way. Okay. So each one of these motors is on a different branch, on a different circuit. And it might be that maybe one of these motors gets overloaded and draws too much current. And so you want to put in some sort of a circuit breaker that stops this motor, but you don't want to shut down the entire robot. You just want to shut down this one motor. So what you can do with this power distribution panel is you can have separate circuit breakers for each different branch. These slots that you see right here, these slots that you see right here, those are slots where you plug in the breakers. And this, okay, here's a picture where you see that we've got different breakers plugged in. And so let me switch to a different color. It's going to show up a little bit better here. So the breaker you see right here is protecting this branch right here. And it's a 40 amp breaker. So remember, an amp is a measure of how much electricity is flowing. So if the motor that's connected to these points right here, if something goes wrong with that motor and it starts to pull more than 40 amps, then this breaker here will flip and it will stop the electricity of that branch, but the other breakers will still keep going. So it'll only stop that one branch. By the way, I didn't tell you this, but there is going to be a homework assignment tonight. You are going to have to take a quiz. So I trust you're taking notes of everything that we're doing here. All these questions that I'm asking are going to be, or these things that I'm discussing are going to be quiz questions. Okay, so these breakers that you see right here, okay, these are all plug-in breakers. And this is what they look like, right? Whoops, okay, right here. Okay, this what you see in the upper right here, that's one of the breakers that I've pulled out just so that you can see what it looks like. And these breakers come in different varieties. For the big, oops, I keep forgetting I have to turn on annotation before I touch my screen. So for the big motors, we hook them up with 40 amp breakers. And in a few minutes, I'm going to talk about different types of motors. Not all of the motors that we use are big, powerful motors. Sometimes we use medium or small size motors. And so they don't need 40 amp breakers. They could get by with a 30 amp or even a 20 amp breaker. We'll talk more about those later. But this is basically, whoops, didn't mean to stop sharing. Okay, so this is how this works. Okay, so let me go back to here again. All right, so every time I switch slides, I have to turn annotation off and then back on again, so it's really annoying. Okay, so let's track the flow of the electricity again. So it starts off in the battery. It comes through the main breaker into the power distribution panel. PDP stands for power distribution panel. Okay, and then let's say that we're interested in this motor right here. So if you trace the lines, you can see that it's coming out from this particular wire. So the electricity is going to come out through this red wire, going to flow along here, but it does not go directly to the motor. It needs to go through a motor controller. Because remember how motor controllers work and why you use motor controllers. The motor controller is the thing that's going to give it a pulse width modulation to the motor. So that if we want to run the motor at half speed or quarter speed or 2/3 speed, okay, the RoboRio will send a signal to the motor controller, telling the motor controller what it wants the motor controller to do. The motor controller will then send pulse width modulated power to the motor. So it'll run the motor either full speed or half speed or whatnot. And the motor controller can also run the motor either in the forward direction or the reverse direction. So you definitely have to go through a motor controller before you get to the motor. And the motor controller needs to be connected to the RoboRio because they have to communicate with each other. All right. So then it goes through the motor controller, it runs through the motor, and then it comes back on the black cycle, goes back into here, and then gets routed from here back to the ground. Okay, so that is the full cycle that you use. It is identical to what we did with the smaller robots. It's just that we're using circuit breakers, which we didn't before. And we're also using a power distribution panel with circuit breakers on each of the different circuits there, so that we can cut the power to one branch if something goes wrong in that one branch, but yet maintain power to the other branches. Okay, but the theory is exactly the same as what we've done before. All right, so let's go back here to this picture. All right, so this right in here, these are just 4 different motors, and there are different types of motor controllers. Up until now, whenever I've talked to you about motor controllers, the ones that I held up as examples were this motor controller, which is used for brushed motors, and this motor controller, which is used for brushless motors. But this is only one of many different types of motor controllers that are out there. In fact, let's take a minute, let's talk. When you go into the lab, you're going to see that we have a bunch of different motor controllers. Okay, let's go to here. I'll come back and talk about this. Okay, so this is called a Jaguar motor controller. It's, hang on, I just dropped something. Okay, this is an old style motor controller. We try not to use it too much anymore because it's not as reliable, and it has to be this thing that you see right here. This is a fan that helps keep it cool. The new motor controllers don't need fans, but these old motor controllers, if you didn't have a fan on them cooling them down, they would overheat, and then you'd have trouble with them. So you're going to see that we have a bunch of Jaguar motor controllers lying around. Hopefully we won't have to use them, but if we run out of the other kind, then yep, we'll pull these out and we'll use them. Okay, this one is the newer kind. This one is made by a company called Talon. And this is a similar one. This is made by a company called Victor. The Talons and the Victors work very, very similar, except for the way that they talk to the RoboRio. The way they communicate with the RoboRio is a little bit different, and we'll talk about that in a few minutes. But for most intents and purposes, you can pretty much use these two interchangeably. This is a relay. This is a mechanical relay. So remember with relays, the thing about relays is inside the relay, there's a little kind of like an arm, a little finger is probably a better thing to describe it as, that physically moves one way or the other. So you must never pulse width modulate a relay. You'll destroy the relay if you try to pulse width modulate it. Relays are good for motors when you're going to turn the motor on and you're going to run it at full speed. Then a relay is a good thing to use. But you could also use a motor controller too. It's just the motor controllers tend to be a lot more expensive than relays. So if you're doing an application where you don't really need a motor controller, then please use a relay. And this is a smart relay. This relay is actually an H bridge. So what that means is inside this relay, there's actually 4 relays that work together in the H bridge form, so that this can run the motor full speed forward, or it can run at full speed in reverse. But it cannot run it at half speed or quarter speed or 2/3 speed. It has to be full speed or nothing, but it can be forward or reverse. This is made by a company called Spike. So if you hear me talk about a Spike relay, this is what it is. So these are much more, they can handle much more power than the little relays that we've worked with up until now. Okay, this is a whole bunch of relays all put in together that are used whenever we're doing pneumatics with our robot. So pneumatics is where you've got air pressure that runs something. Like for instance, this is a pneumatic cylinder. And so what I can do is I can hook it up to a pressure pump. And if I put air pressure in this one side, watch this little blue tip and watch what happens when I blow in this side. You see how that goes out? And then when I blow in the other side here, watch the thing again. You see how it comes in? Okay, so if we hook this up to high pressure air, this thing right here can come shooting out super fast and super powerful. In fact, very dangerous. You could kill somebody with this if you're not careful. Okay, so sometimes, depending on the application, we may want to use pneumatics. And so the valve that opens and closes the air pressure switch is called a solenoid, and you need a relay in order to operate that. So you could use a Spike relay, but you don't really need all of the power that a Spike relay can carry. And so what we have here is a bunch of different relays all packaged together. So there's like you can run 4 different solenoids from this side right here. And you can run 4 more solenoids from this side right here. So you can actually control 8 different solenoids, where remember, a solenoid is the valve that opens and closes to let the air pressure flow or not let the air pressure flow. So this one little package is actually 8 different relays all put into one. So this is called a pneumatics control panel. It's basically just a bunch of relays is all it is. Okay, so let me go back here. See here. All right, so what you're seeing here is the RoboRio, and what you're seeing on the left. So this is the RoboRio, which, like I said before, is basically an Arduino's big brother. And then this is the Spike relay. This is the Jaguar. So the RoboRio needs to talk to these somehow. It needs to communicate with them to tell them what it wants them to do. Okay, so there are 2 ways of doing this. The simplest way, the one that's conceptually the simplest, is that you can connect these up to these ports right here, either the port on the right or the port on the left. You can wire up something that goes to the motor controller and then comes back to here. And then if you have another motor controller or you have another relay, you have to have another set of wires that goes from here to here. And let's suppose you've got like 7 motors or that you want to run on your robot. Each motor controller is only allowed to run 1 motor. And so what that means is you have to have, for each motor controller, you have to have 2 wires going directly to the RoboRio. And there is a limit on how many ports on the RoboRio you can use. So, I mean, if you have a lot of different motors and you're also, these ports are also used for sensor input and stuff, it's possible that you might have so many motors and so many sensors that you're going to run out of ports to plug them into on the RoboRio. So direct connection to each motor controller is conceptually simple, and works great as long as you don't have too many of them. But if you have a lot of them, then rather than using direct wire communication like that, then what you want to do is you want to set up a communications bus that is called a CAN bus, where CAN stands for Controller Area Network. I mean, in your computer class, have you heard of LAN? You know, a LAN network? It's kind of the same thing. LAN networks are used for computers. CAN networks are used for like RoboRios and things. And so with a CAN bus, all you need are two wires that go to the thing. So the master here, that would be the RoboRio. Okay. So you only need to connect two wires to the RoboRio. And then these wires, they go to the first motor. Now this node here is generally going to be a motor controller. But it doesn't have to be a motor controller. It could be a sensor or it could be something else. So then these are all daisy chained together like this. So, and then each one of them gets a unique ID. So when the RoboRio wants to send a message, let's say this is ID number 1, number 2, number 3, number 4. So the RoboRio wants to turn on the motor that's connected to number 4, or sorry, number 3 here. So what it does is it sends out a signal, and everybody on the network sees the signal, but the signal says that, hey, the following message is intended only for node 3 on the network. So if you are node 3, then you pay attention to this network. But if you are any other node, then just ignore the following message, and then it sends out the message, right? So everybody hears the message, but only one of them will act on the message. Okay, so this is called CAN bus communications, and it's a lot cleaner for wiring it up. The programming of it is a slightly more complicated, but not bad. Okay, and so now the reason you need to know about this is because when you're hooking up your motor controllers, let's see, let's go back down to here again, sorry. Okay, so when you're hooking up your motor controller, you need to know how does the motor controller communicate with the RoboRio. You can see here that the Talon uses CAN bus. Okay, so when you connect this up to the RoboRio, you're going to connect it up to the wires that are part of the CAN bus. The Victor, which is this guy, well, hang on a second. Okay, here we go. So the Victor, it does not communicate via the CAN bus. It needs to have a direct connection to one of the ports on the RoboRio. Okay, so that's the main difference that you need to worry about between the Talon, which communicates with the RoboRio through the CAN bus, and the Victor, which communicates with the RoboRio through the I/O port on the RoboRio. Okay. Let's see. So what else should we talk about here? Okay, so pulse width modulation. You guys understand how pulse width modulation works. There are two types of pulse width modulation. So let's suppose that you're a motor controller. Okay, so let me turn on. So here's the motor controller. Here's the motor. Okay, and then here's the RoboRio. Okay, so the RoboRio sends a signal to the motor controller. Motor controller then will pulse width modulate the power that's going to the motor. So what you're seeing here, this is how the motor controller is going to be sending power to the motor. So if we want it to run at a 20% duty cycle, that means we want the motor to run at 1/5 of its full speed. We somehow tell the motor controller that's what we want. And so the motor controller will then give power to the motor for a very brief time, for 1/5 of the time. And then it'll be off for 4/5 of the time, and then on for 1/5 and off for 4/5. Whereas If we tell the motor controller that we want it to run at 60% speed, then it'll be on for 60% of the time and off for 40, on for 60, off for 40, and so forth and so on. So this is what's happening between the motor controller and the motor. Okay. Now, how does the Robo Rio tell the motor controller that that's what it wants? Well, that is the second type of pulse width modulation, which they really should have given it a different name. But this is the one where, remember how when you send a signal, oops, hang on a second here, my computer's being funny here. Okay, remember how it is that you can send a signal every 20 milliseconds. Okay, so here's one signal, and then 20 milliseconds later, you send another signal. So if that signal is 1.5 milliseconds wide, that is a coded message to the motor controller that tells the motor controller that you want it to stop the motor. If this signal that we send every 20 milliseconds is 2.0 milliseconds wide, that is a coded message that tells the motor controller that we want it to go full speed forward. Okay. If, on the other hand, this signal that we send every 20 milliseconds is 1.0 milliseconds wide, that's a coded message that tells the motor controller that we want it to run full speed in reverse. Okay. And if it's somewhere in between 1.5 and 2.0, then that's going to be partial speed forward. And if it's somewhere in between 1.0 and 1.5, that's going to be partial speed reverse. Okay. So this method is also called pulse width modulation, which is, like I said before, is an unfortunate name. I wish they'd called it something else, because this and this are very different schemes. But anyway, that's the way they work. Okay. So let's see what else we need to talk about here. Okay, so we've talked about the different types of motor controllers. Let's talk about the different kinds of motors. All right, so up until now, there have been many times when I have held up a motor and it's okay, so this is the kind of motor we're going to be dealing with a lot. This motor is called a CIM motor, CIM. And I've seen different explanations for what CIM stands for. The M definitely means motor. But the C and the I, I've seen different explanations for what they mean. So I'm not really sure which one to believe. But anyway, so this is a very powerful motor. When we want to drive the motor forward and backwards and stuff, this is the motor that we've been using for many, many years. It's a pretty good motor, very powerful, reasonably reliable, but not the greatest. And so recently, we've been switching over to these motors. These are brushless motors, whereas this one is the old style brushed motor. So lately, we've been using more and more of these brushless motors, and we've been very happy with them because the advertisements about them are true. They are more reliable, and they are lighter, and they are as powerful. And they also, the nice thing about these brushless motors is they have a built-in encoder. So if we tell it we want, let's say we want to turn the motor 147 times and then stop because we want the robot to move a certain distance. And you guys have experienced for yourselves the pain and frustration of open loop motor control, right? You tell the motor to run for 3.7 seconds and you give that same command to both motors and you hope that the robot runs straight and stops at the same point every time you do it. But what you find is that that two motors are never exactly the same, right? And so the robot doesn't really run straight. And if you repeat the test 10 times, you find out the robot doesn't stop in the same spot every time, right? So the better way to do it is closed loop motor control. In order to do closed loop motor control, you need to have a sensor built into the motor so that you know exactly how many times the motor has turned. Okay, so these brushless motors, they have the sensor built into them. So they are definitely a better way to go. Okay, but for the first couple of motors, first couple of robots I have you build, I think I'm going to have you guys work with the old style brushed motor, just because they're a lot simpler to run, to wire up, and they're a whole lot simpler to program. Okay. All right. So these big motors here, these are called SIM motors, CIM. Now, if you are building a robot which you plan to compete at a first robotics competition, which by the way is what FRC stands for. Okay, FRC, that stands for First Robotics Competition. That's the name of the robot group, the robot organization that Ames participates in when we have our competitions every year. Okay, so they have rules about how many motors you're allowed to use and what kinds of motors you're allowed to use. So their rules say that you're only allowed to use 6 of these SIM motors, which is usually more than enough. Okay, but there are other kinds of motors you want. This, what you're seeing here, is a motor made by a company called BaneBots. It's smaller, not as powerful, but if you're doing something like you've got an intake where you want to pick up a ball, and you're not driving the robot, you're just picking up a ball, or maybe you've got a bunch of you've got a transport system inside your robot where you want to take the ball that you've just picked up and you want to deliver it to the shooter, which is going to shoot it out. You don't need a big, powerful, heavy sim motor for that application. You can use smaller motors. So, and with these smaller motors, there's no limit in the FRC rules on the numbers. You can have as many of them as you want. Now, there is a limit on how many ports are available in your power distribution panel here. Okay, there is a limit here to how many ports you have, and so you can't just go crazy and use totally unlimited numbers of motors. But according to the competition rules, there isn't any limit there. So this is called a BaneBots motor, we will probably be using some of these in some of our robots. This is an Andy Mark 9015 motor, which again is not as powerful, but it's lighter and it's good for many applications. This is called a throttle motor. We've got a whole bunch of these. Somebody donated a big box full of throttle motors, so they're really nice to play with, just because we got so darn many of them. This is a motor that looks like a sim motor, but it's smaller, and it's called a bag motor, or sometimes it's called a mini sim motor. This is a motor that we call it a window motor or a door motor. If you were to look in your car, if you were to take the door from your car and open up the door and look on the inside, this is the motor that makes the window go up and down. We have a bunch of these, and these are really nice because they run at a really good speed. They're very useful for a lot of applications. And so I think that's pretty much it for the motors there. So these are the different types of motors we're going to be working with. Okay, so this slide here just shows how the various things communicate with the RoboRio. So depending on what motor controller you're using, some of the motor controllers have to be connected up to the I/O ports on your RoboRio, where others of your motor controllers can connect up to the CAN bus. So that's just what that is. We've already talked about that. The pneumatics, I think I'm going to skip over that today. We're not going to be doing any pneumatics controls right away. We will before the school year ends. We will build robots that use air pressure in order to do things, but not initially. So I think I'm going to skip over this. This we've already talked about. This is the pneumatics controller, which is basically just 8 different relays all built into one little package, which is really nice and convenient. Oh, and by the way, it's worth pointing out, you see right here where it says CAN bus interface. So this is where you plug in the CAN bus wires. And so notice there are 4 places where you can plug in wires, because you need to have you need to have the two wires that are coming from the node to the left of you. And then you need to have two wires that go over to the node to the right of you. Okay, so your CAN bus connections need to have openings for 4 different wires. And then the relay needs to have a place where it can plug into the power. Um, so that's what that's all about. So this is the pneumatics controller, which we won't be using right away. So we're going to skip over that. Okay, what you're seeing circled here is something that we're also not going to be using right away, but just so you know about it, the Robo Rio is very smart. And what you can do is you can connect up a camera to the Robo Rio. So the Robo Rio then can receive an image and analyze the image and decide what to do based on the image. So like, for instance, if there's a certain target that you want to shoot balls into, the Robo Rio can look at the camera, can recognize where the target is, and then it can direct the robot. So the robot will turn and drive toward the target, and it'll stop at a preset distance away from the target, and then it'll shoot balls into the target. So in order to do that, you need to have a camera. And the camera needs to get its power from somewhere. And so rather than hooking the camera directly to the power distribution panel, it's a good idea to have a voltage regulator, because this battery, well, when a battery is fully charged, it might have as much as 13 volts on it. And then as you drive the motor, the robot around, the voltage is going to drain. And so your battery is going to drop down from 13 volts down to 12 volts, and it might even go as low as 11 volts. And so the power that's coming out here is going to vary accordingly to that. Cameras tend to be kind of finicky. Cameras work best if they always get the same voltage. And so what you want is you want a voltage regulator. And what it does is it receives voltage from the power distribution panel, and then it outputs a slightly lower voltage, but the output voltage is always going to be constant, even though the input voltage might vary quite a bit. So it's a good idea to have a voltage regulator. And this is what a voltage regulator looks like. Okay, so the input to the voltage regulator is right here. And you can see it's unregulated 12 volts input. So what that means is, don't be surprised if it's actually 13 volts. And don't be surprised if it's actually 11 volts. It's going to vary a lot. Now the output here, we've got a 5-volt output. And we've got an output in these ports that can handle as much as 2 amps, which some applications might need, but maybe not every application needs that much current. So we have these other ports over here that are also 5 volts, but their maximum is 500 milliamps, which is, a half of an amp. Okay, but then over here we also have regulated 12-volt output. So the output here will always be 12 volts, even though the input is not necessarily 12 volts. So that's a voltage regulator. It's something that you're going to find is a very good thing to use. And then other things that you can plug into the Robo Rio are things like joysticks in order to control it, and maybe a radio, because instead of having a wire running from your joystick to the robot, you probably would prefer to communicate wirelessly with the robot. And so you're probably going to want to have a radio, which is also sometimes called a bridge access point. And there are different types of cameras. Some cameras are Ethernet cameras, other cameras are USB cameras. The Robo Rio is pretty flexible in that regard in what types of cameras you're allowed to use. Okay. So this picture that you see right here at first glance looks really overwhelming. But you'll see that it's actually not that bad. You'll get used to it. Okay, the last thing. The last thing we're talking about here is when you have a big, powerful robot, you have to recognize that it's dangerous. And you need to somehow warn the people around you that this robot is powered up and it might possibly move. So one of the rules that the first robotics competition enforces is that every robot has to come with a thing called a robot signal light. And so what that means is when the robot is enabled, this signal light needs to come on. And in fact, actually, when the robot is powered up, the signal light comes on solid. And then when the robot is enabled, which means that it is communicating with the driver, so that if the driver uses the joystick, the robot's going to move. In that case, the robot signal light needs to be blinking, so that anybody in the vicinity, they know that this robot might move at any time. And so they know that they need to keep a good distance away from the robot. Okay. So this is the signal light. Okay. So I have hit you with a whole bunch of information. I realize, that's a lot to take in all at one time. And that's why I've posted a couple things on Canvas that I think you'll find will be helpful. Okay, so let's go to, so if you go into Canvas, so when you go into Canvas, you're going to see that under the module of Bigger, Stronger Robots, I have put a quiz on here. This quiz is due on March 25th, which is this coming Thursday. So it's due at midnight this coming Thursday. And this will be the last assignment that'll go on this term's grade. Make sure you do it. If you were taking careful notes when we went through everything that I did just now, then you should be in good condition. But just in case you didn't, here is a little video that basically says the same stuff that I just said, but I like the way that it's done. In fact, let's take just a couple minutes. I'm not going to show you the whole video here, but I am going to show you a few snippets here and there. I really like the way this video was done. What they do is they show you a robot, and they start off with just the simplest possible configuration. Okay, well, if it'll ever load, it will. Okay, here we go.
Okay, here's our basic
Okay, so
FRC
this
robot.
is the robot,
It
and
has
it
a
looks kind of
big
complicated.
dispenser to drive
So what they
around.
did was they said, okay, well, we're going to start
There's no motors,
with just
so
a
let's start
base
with the
robot
battery.
here. And then we're going to build it up piece by piece.
Run some
So,
electricity through it.
okay, so here what they've done is they've taken the battery, they've connected up to the main breaker, and then here is the power distribution. Okay, and then they move forward a little bit to here. Come on. Boy, it's taken a long time to catch up here. Boy, my internet is really slow here. Okay, so it looks like the internet's not going to cooperate, but basically, so then they're going to add a motor. They're going to connect it directly to the motor without using a motor controller, which hopefully you guys realize you can only do if it's a brush. Okay, so here we go. So you can only do this if it's a brushed motor. Never, never, never connect a brushless motor directly to the battery. But if it's a brush motor, you can. And so that's what they've done here. And so then they turn on the motor controller, the motor, and you see it works. But of course, the motor only runs at full speed if you do that. And so the next thing we want to do is we want to put in a motor controller. All right, so now you're seeing the motor controller there. But then you need something to tell the motor controller what to do. So that means then you're going to need a Robo-Rio. So, boy, my internet is just so slow here for some reason. But basically, they build it all up step by step by step. So it's a great video. I highly, highly encourage all of you to watch that video. Okay, so let me get it back out of here. Okay, so let's go back into the quiz here. So after you've watched this video here, Then if you still want additional information, here is a PDF file, which, okay. Why is it not wanting to open up? I'm really worried about my computer here. It seems to not be working. Maybe it's because I'm in student view here. Maybe let me get out of student view here. But anyway, so there's a PDF document that you can download that pretty much describes everything that you need. Okay, so after you've watched the video and looked at the document there, then if you go into the quiz, then you'll see that there's a bunch of questions in the quiz that I just want you to answer. And they're pretty straightforward. So what is this component? What does it do? What is this and what does it do? What is this and what does it do? You know, and so forth and so on, just all the way down. So once you answer all those questions, then submit it and then we're done for the term. Okay, are there any questions about anything that I have just gone over? Not seeing any, not hearing any. All right, so you understand you do have a homework assignment. It is due on Thursday. It is going to go on this term's grade. So make sure you do it.
I got a question.
Okay, yeah, go ahead.
Could you repeat what you said for like the past since 220?
Nope. Go back and watch the recording. So did the internet lock up where you guys weren't able to hear me for several minutes? Is that the case?
No, I'm just kidding. But it did like cut out for 20 seconds sometimes.
Okay. All right. Well, in that case, well, if you need to go in and watch the video, you can. I'm recording everything that we're doing right now. And so it takes about an hour to process the video. So about an hour from now, if you look on Canvas, everything that I've done for the past 50 minutes will be posted on Canvas. So you can watch that again. But also the video that I posted on Canvas along with the assignment, that will also pretty much answer all of the questions that you might see on the quiz. Okay. All right. So you do have an assignment. It is due on Thursday. It is going to go on this term's grade. Make sure you do it. It's on Canvas. So if you don't have any questions, then you can go ahead and type by in the chat box and head out. If you do have a question, but you didn't want to ask because you knew it was being recorded, here, I'll go ahead and stop the recording so we can talk without it being recorded.